Electric charges, properties of the elementary particles because of which they exert the force on other charges. So for example, if I consider the elementary particles like proton, proton, or electron, electron, or proton, electron, between proton and proton there is a repulsive force. Between electron and electron there is a repulsive force. Between the proton and the electron, or with the electron and proton, there is a attractive force. If I consider proton and the neutron, there is no any force between them. Between neutron and the electron, there is no any force between the two particles. Therefore, the elementary particles like proton exert force on another proton. Electron exerts force on another electron. Proton exerts force on electron. Similarly, electron exerts the force on the proton, but not proton on the neutron or electron on the neutron. Therefore, proton, electron, they have the property to exert the force on the other particles. That property is called as the electric charges. Therefore, proton and electron has electric charge. Now, if I consider any proton or the electron, they have equal amount of the charges. Okay, so if I consider an electron, right, or the proton, the charge possessed by them is equal, but opposite. Now, let me consider the types of the charges. Types of charges. Now, we have two types of the charges. With respect to proton, we have positive charges. With respect to electron, we have negative charges. Okay, proton possesses positive charges, whereas electron possesses negative charges. Two types of the charges, positive and the negative charge. Now, in an atom, number of the proton is equal to number of the electron. The charge on the proton is always equal to charge on the electron. Each proton carries a charge of plus 1.6 into 10 raised to minus 19 coulomb. Similarly, an electron possesses a charge of 1.6 into 10 raised to minus 19 coulomb. Coulomb is the SI unit of the charges. So therefore, this quantity, that is plus or minus 1.6 into 10 raised to minus 19 coulomb, is called as electronic charge. Okay, so therefore, electronic charge, which is represented by E, is always equal to plus or minus 1.6 into 10 raised to minus 19 coulomb. This quantity is taken as electronic charge. You should remember this one. Electronic charge, E is equal to plus or minus 1.6 into 10 raised to minus 19 coulomb. Okay, so this is the definition of the electric charges and the types. Now, if I go with the properties of the electric charges, we have three basic properties of the electric charges. One is additive property. Let us see what this additive property is. Say for example, I have a conductor, right? I have a conductor which is charged with plus 2 coulomb. Now, if I add 1 coulomb of charge to this conductor, then total charge on the conductor will be plus 2 plus 1, that is 3 coulomb. Now, if I add further minus 2 coulomb, then total charge will be, right, Q is equal to 3 minus 2 coulomb. Okay, so that means you can add the charges algebraically. So that is called as the additivity of the charges. Now, second one, that is quantization of the charges. Very important one, quantization of the charges. Now, say for example, there is a conductor. Okay, so initially, if I consider a conductor possessing of large number of the atoms, right? In case of the atoms, number of proton is equal to number of the electron. Therefore, total number of proton on this conductor is equal to total number of the electron. Now, each proton carries a charge of plus 1.6 into 10 raised to minus 19 coulomb, and each electron carries a charge of minus 1.6 into 10 raised to minus 19 coulomb. Therefore, the net charge, they get cancelled with each other. Therefore, net charge always equal to 0. Net charge is equal to 0, but not charge on the conductor is 0. Okay, so net charge on any conductor is equal to 0 because number of electron is equal to number of the proton, and each proton carries a charge of 1.6 into 10 to minus 19 coulomb. Each electron carries a charge of minus 1.6 into 10 to minus 19 coulomb. They cancels with each other. Okay, so therefore, now if I set a charged conductor, negatively charged conductor, that means number of electrons must be greater than number of the protons in the conductor. Then it is said to be negatively charged conductor. Okay. Now, see here, how to charge it. I want to make this conductor negatively charged one. Okay. So basically net charge Q is equal to 0. Now, if you want to make this conductor negatively charged conductor, goes on adding the electron. Okay, right. Initial charge is equal to 0. Now, if I add one electron to this conductor, then charge on the conductor becomes minus 1.6 into 10 raised to minus 19 coulomb, or that is equal to 1 into, this quantity is called as, right, electronic charge E. You can take this one as minus there. Okay, right. Similarly, if I add one more electron, then charge of the conductor becomes, right, 1.6 into 10 raised to minus 19, right, into 2. That's equal to 2 into this quantity is electronic charge. Similarly, if you add 3 electron, then this becomes 3 into E, right. Similarly, if you add n electrons, then total charge on this conductor will be n into E. That means in general, right, in general, charge on any conductor will be given by Q is equal to n into E, where n is the integer like 1, 2, 3, 4, so on to n. Okay, so that means charge on any conductor will be integral multiple of electronic charge. Okay, so this is called as the quantization of the charges. Therefore, according to quantization of the charges, the charge on any conductor will be integral multiple of electronic charge. If it is a negatively charged, take it as minus. If it is a positively charged, take it as plus. Therefore, you can write plus or minus n into E. Okay, say for example, we'll consider an example. Okay, example is like this. How many electrons makes a charge of minus 1 coulomb on the conductor. Okay, how many electrons makes a charge of 1 coulomb, minus 1 coulomb on the conductor. Okay, so here charge on the conductor must be is equal to minus 1 coulomb, or magnitude wise 1 coulomb. Okay, to get minus 1 coulomb of charge, how many electrons should be added to the conductor? That means here number of the electrons, that is n, is to be calculated, right? charge on the conductor should be 1 coulomb, right? We know the value of E, that is 1.6 into 10 raised to minus 19 coulomb. Therefore, using the quantization of the charge, Q is equal to plus or minus. Okay, here it can take minus N into E, right? Q is equal to N into E implies N is equal to number of the electrons, N is equal to Q by E there. Okay, now put the values. Q 1 divided by 1.6 into 10 raised to minus 19 coulomb. Okay, so this much of the electrons are required to charge a conductor, right, equal to 1 coulomb. Okay, so this is about the quantization of the charge. According to quantization of the charges, right, charge on any conductor must be integral multiple of electronic charge. Okay, now let us move to the third one, right? Second one quantization, now third one, that is conservation of charges. Okay, so we know the law of the conservation of the energy. Energy cannot be destroyed, cannot be created. Like that, here also you cannot create the charges or you cannot destroy the charges. Say for example, we have two conductors like this. Two conductors. Okay, initially number of electron is equal to number of the proton. Here also number of the electron is equal to number of the proton. Now, if you want to make this one negatively charged conductor, add the electron now. Okay, now if you add the electron, then number of electron increases compared with the proton. It does not mean that here number of the electron increases, it does not mean that we have created the electron, because to add the electron here, we have to remove the electron from this one. Therefore, how much electron increased here, same quantity of the electrons will be decreases here, so that total electron of the system remains constant. Okay, so that is the law of the conservation of the charges. Total charge of a system always remains constant. Okay, so this is about the properties. These are said to be basic properties. Basic properties, okay, of the charges. You have to write, if you asked give the properties of the charges, then you have to write the basic properties like additivity property, quantization property and conservation of the charges. Okay, so besides of these things, we have some other properties of the charges, like fourth one, right? Charge is the scalar quantity. Okay, the magnitude of the charge do not depends upon the direction, okay, of the charge there. Then if I go for the fifth one, speed, it is independent of speed. Of speed. What do you mean by independent of speed? That means the magnitude of charges always remains constant. It do not depends upon the speed. Say for example, electron charge is equal to 1.6 into 10 raised to minus 19 coulomb. Okay, charge on the electron is minus 1.6 into 10 raised to minus 19 coulomb. Okay, it do not changes. Okay, whether the electron moving with the fast manner or moving with the slow manner. Okay, because this magnitude is independent of the speed of the charge. Okay, so this is the fifth property. Then if I go for the sixth one, of course you know this one, right? Like charges repel, whereas unlike charges attracts. Okay, so for example, if I consider a proton, that is going to repel another proton. If I consider an electron, that is going to repel another electron. But if I consider the proton, it is going to attract another electron. Like charges repels, right? Whereas unlike charges attracts with each other. That is the sixth property. Then if I go for the seventh property, okay, seventh property, the body which gains the electron becomes negatively charged. The body which loses the electron becomes positively charged. Say for example, if you want to make a conductor positively charged, remove the electron from it. Okay, if you want to make the negatively charged body, then add the electron, because a body which gains the electron becomes negatively charged, which loses the electron becomes positively charged body.